Hi everyone, I'm starting a new playlist on solid principles. So these are 5 key design principles in object-oriented programming that help us build better software. The term solid is itself an acronym for S for single responsibility principle, O for open closed principle, L for Liskov substitution principle, I for interface segregation principle, and D for dependency inversion principle. So by using these solid principles, we can easily write code that is easier to understand, easier to modify, easier to extend, and we will also be able to avoid some common pitfalls like tight coupling, code duplication, and hard to maintain logic. In this video, I'll be discussing the first principle of the solid principle, that is single responsibility principle. And the core idea of SRP is simple. A class should have only one reason to change. If we are able to identify more than one reason in which we will have to change the class, then that's the violation of SRP. So in order to understand this principle, I will be taking help of two examples. First one is report management. So let's see this Python code example. So in this code, we can see I have declared a class report and it has got a constructor. The constructor takes a parameter called content, and it is doing what it is assigning this content thing to self.content. There is one method called save to file, and it is taking an additional parameter called file name. Whatever is the file name, it is opening that file and it is writing self.content there. There is third method, okay, print report. Okay, what it does, whatever is the self.content, it is just printing that. So this is the bad example in Python. Let's see what is wrong with this example. So the problem in this approach is that first of all, it is a clear violation of SRP. This class is handling three different concerns: data storage, okay, whatever content we are passing, it is saving as self.content, and whatever is the self.content, it is saving that into file. Okay, so it is also handling file handling, and it is also doing printing, okay, using the third method, print report. So it is handling three different concerns, and obviously one class should handle only one concern, one responsibility as per the single responsibility principle. Second one is hard to maintain. Why is it hard to maintain? So right now what we are doing, we in this save to file method, we are opening the file name and we are writing whatever is the self.content. So suppose we don't want this to happen. Okay, if we want to save this content, self.content, we just want it to save it to some database instead of to a file. So we will have to modify this whole class. In order to make this change, we will have to modify this save to file thing, okay, save to file method. And while we are modifying this method, we are modifying the whole report class because it is part of the report class. So the thing is that since we are only modifying this save to file method, we are also risking modification of other methods also. Suppose the developer is modifying the logic of the code, and in the logic of the code there is some variable that is being used by other methods also. Like there is some mistake done by developer unknowingly that is affecting the performance of print report and other methods as well. Okay, so this is also possible. So this is why it is hard to maintain. Third one is difficult to test. So why is it difficult to test? Because in order to write test for it, we will have to write test for all three together. Okay, because all three are there in the same class. Okay, if we want to just write test for save to file, we will have to create instance of report class, and obviously report class has got all these three methods. So writing tests are difficult in this case. If there have been only independent piece of code for saving, printing and all those stuff, we could have just written test for those individual parts only, not the whole class. Okay, and it is not reversible. Okay, right now this print report and save to file are tightly coupled with this report class. So those are belonging to only this report class. Now suppose there is some other class which want to make use of this save to file and print report logic. Okay, so in that case what we will have to do, we have to declare these two methods there also, and since we want the same functionality there also, we'll be writing the same exact code or same exact logic there also. This is duplication of logic, duplication of code, which is obviously not a good practice in software engineering. So these are the problems in this approach. Now what I will do, I will refactor this code and we will see a good example for this particular report management thing. So this is a good example in Python. What is happening here? We have this report class as usual, and it is having the as usual constructor, like content will be sent as a parameter and it will be assigned to self.content. We have declared a new class called report saver. Okay, so in this report saver class, there is a static method save to file. Okay, it is taking some report object and the file name, and it is opening the file and it is writing the report.content there as the same behavior as the previous one. And we have also declared one report printer class. It is also having the static method print report, and it is again printing report.content. So we can see that logic is same, but now we have divided this whole thing into 3 different classes. Now let's see what is the benefit of doing this. So first of all, better maintainability. Here, suppose as discussed, we want to change file handling logic, like to saving to some database. So in this case, we will have to only make change to this report saver class, because save to file method is part of this report saver class only. It has nothing to do with report printer and report class. So even if there are changes in it, it is not going to affect this report printer and report class, and thus we are now avoiding risk to failure of these classes. So even if some developer will write some buggy code or non-working code after modification for report saver, it is only going to affect report saver. It is not going to affect the working of report class and report printer. Okay, it is only going to affect this report saver. So we will have to only test working of report saver after the modification. We are ensured that this report class and report printer were fine before this change, and they will remain fine even after this change of this save to file logic. So yeah, improve testability. So now if we want to write test, we can write separate test for report, we can write separate test for report saver, and we can write separate test for report printer. So for every logic, for a printing logic, there are separate tests. For a report saver logic, there are different tests, and there are different tests for reports. So writing test is much easier. Now we won't have to put redundant stuff, okay, redundant dummy data, which were not needed in previous scenario for writing test. And reusability. So the best thing is that we can make use of report saver and report printer in different project. We don't need to declare report saver separately for them, and yeah, we will be able to avoid code duplication and logic duplication. So now take a look of another example. This is user management. So here is a Python snippet. In this, what I have done, I have declared a user class. Okay, it has got a constructor, and it is having 2 additional parameters, username and email. Both are being assigned to self.username and self.email. Now there is one method, save to database. So what it is doing, okay, obviously in your real implementation there will be lot of other examples, lot of other stuffs, a lot of other logic in here, but to make it simple, it's just printing, like saving self.username to database. It is making use of self.username thing. Okay, and in this send underscore email, this is the method for sending email. It is taking some message and it is sending that email to whatever the self.email is and whatever message we have provided it. Now take a look to what are the problems with this particular code snippet. So obviously we can see this is violating SRP, single responsibility principle, because right now there are more than one responsibilities for this user class. It is also saving to database, it is also sending email. So the issue with this code is that database and email are unrelated. So storing user data has nothing to do with email sending. For sending email, we don't need what is the username of the user. So this send email method is unnecessarily having access to self.username. Okay, it is not making use of self.username, but it can make use of this self.username, but it is in its scope. Any developer can accidentally make use of self.username. It can also modify that. We are putting all these things unnecessarily, which are not related at all. Okay, and tight coupling. So we can see that if email logic changes, right now what we are doing, we have written our own logic how we are going to send email. But suppose in future we want to make use of some external email service, so we will have to modify this particular snippet of code. And to modify this particular snippet of code, what we will be doing? We'll be making changes inside this particular method. But since we are making changes in this particular method, it is part of this whole user class, and it may affect save to database and other functionality. It may break them, it may make them non-working. So this is the problem with this particular implementation. Now what is the third one? Third one is poor reusability. So again, if someone else want to make use of the save to database functionality and send email functionality, it will have to write their own method in their classes. And again, that is obviously code duplication and logic duplication, which is never wanted. So how can we fix this? Again, what we will be doing, will be creating one class for user, which will be storing username and email that is, that is set during its instantiation. There is a separate class called user repository whose function will be to save to database. It will be having a static method called save to database. Just provide the user and it will save user.username to database. And there is one more class, email service. Okay, it is again having this static method, send email. Okay, so now just if you want to send email, just provide the user object here and just provide the message. It will be sending the message to user.email. No need to provide, no need to make use of self.username. So right now this self.username is totally unrelated with this email service. Okay, it's not going to make use of that thing. Okay, so let us see what are the benefits of this approach as compared to the previous one. So first of all, there is clear separation of concern. In previous example, saving to database and sending email all were packed inside only one class. But right now we have divided the concern. User repository has only to do with handling database operation and email service has only to do with sending emails. Both are not interfering in each other's operation. So suppose right now we are using some database DB1 and tomorrow we wanted to change that. We don't want to save it into DB1. We want to save it into some other database, DB2. So we will have to just modify this save to database method, which is part of this user repository class. It is not going to affect the user class and emails class at all. So we can, make sure that this send underscore email and untouched code is going to work before the code change and after the code change. We don't need to test the code for these things at all, because we know since there are no changes in this part of code, nothing is going to break. So we will be only concerned with the changes in user repository. Scalability. So now we can make use of this email service in other part of the application without database dependencies. So in previous example, what was happening? Send email thing was part of the whole user class that was also having the save to database logic, and save to database is having all those database dependencies, like which database it is going to use, what calls are it is making. So in future, if we wanted to make use of this email service, we are also bringing this database thing in picture, so which was not needed. Right now, if we want to make use of this email service, we can just import this email service class and we can call this send email a static method. We can just provide the object and whatever will be .email of that object, it will be sending the specified message to. So right now this database and email thing are totally separated. So this is how single responsibility help us to write better, maintainable, reusable and scalable code. Hope you liked it.